designed to support families in really understanding some of those key, those foundational concepts that exist in mathematics across all the grades. So tonight we're going to focus deeply in on addition and subtraction and what it looks like across K to 8. In our next upcoming sessions, we'll focus on multiplication, division, and then fractions and ratios. So happy to have so many families come join us for tonight's um, evening of learning. As Umit said, please share any feedback that you have at the end of the evening. The rationale behind this series, focusing in on more mathematical content, is just because last year families really said they wanted support and how to support in ways to best help their child at home in some of the different content areas. So tonight, during this evening's workshop, we're going to spend quite a bit of time together doing math so that we can experience the joy of doing math. Will help build your understanding of how addition and subtraction develops across the grades. And then we'll experience tasks similar to those our students are seeing in the Amplified Desmos Mathematics curriculum as they relate to addition and subtraction, and share ways to support mathematical thinking at home. Hopefully, you'll have fun as we engage in all the mathematics together. So, that being said, I'm going to turn on a poll, and I'm going to ask you to in the poll, it says in the chat, but you can do it in the poll. Think about which turkey best represents how you feel about doing mathematics. So you can go ahead and vote for your turkey, 1, 2, 3, and 4, 5, or 6. Best represents how you feel about doing math. And then if you want to put a rationale in the chat, you can go ahead and do that as well. Seeing a lot of number 2s coming in. Curious to see. I'm guessing doing math just makes you sing out loud. So happy to do math. That's how I feel. I love to like shout it from the rooftop that we're all going to do math together. About a quarter of us feel as though we're number 4. Curious, anybody who put number 4 wants to enter into the chat why number 4 best describes you. We're up to about 30% on that one.
And you can also unmute if you want to speak. There's not that many of us
Yes.
today, so your microphones are open now. You can unmute yourselves.
Louis, is there a way to share the poll with everybody? I can't remember.
I think so. I think you can say after you end it, you can
Uh-huh.
click share results
All right. So let
after
me
you
see. I
end
think
it.
we have a good, looks like we have about 15 people who have gone ahead and entered which turkey best represents them.
I
Couple of
can't believe
us,
no one chose 6. I can't believe it.
I know.
It's
I
crazy.
mean,
Save a turkey, eat the ham.
yeah. Or, do something else other than math.
Look over here.
Read. I
Okay.
wanted to say reading. All right, so I'll end my poll and see if yes, we can share
Yeah,
the
click share.
results. All right. Does it show it in the chat or just everybody can see?
I think
There's,
they see the pop-up, yeah.
yeah, so we have a lot of about a little less than half of us are associating with Turkey too when it comes to doing math, and a little bit more than a quarter of us feel like Turkey number 4, and then a few of us in between. So. All right. I'm going to move us on, but hopefully by the end of the evening, more of us will be feeling like Turkey too and want to sing from the rooftops whenever we are doing math together. Here are just some for norms for tonight. Cameras are optional. If you'd like to share your camera, you're more than welcome. I do ask that you try to be an active participant as we will be doing math. And I will ask you throughout the evening to just share how you thought about that. You can use the chat Or you can use some of the different features that are in the reactions, or you can come off mute to share your thinking. And just my favorite one is just that there's no pressure to be correct. It's really just to be about a night of learning. And yes, Lewis is celebrating over there. Thanks. Okay. So we're going to start the night off by doing a warm up. This warm up is called a number talk. I'm going to show you an expression and ask you to think about how you solved it. For many of us, the first one's probably going to be automatic, but I want you to just still think about how you would solve this problem. Okay. All right. So I want you to determine the value of the expression mentally. And if you can, try to think of more than one strategy. Um, and then once you have a answer and a strategy, you can go ahead and um, put it in the chat or come off mute. Anybody want to share their strategy for how you thought about 5 minus 2? Okay, using adding. Yeman, you want to say a little bit more about that? What that sounded like?
Okay. Go ahead, say it again. Oh, okay, you got shy. My son is 5.5 years old. He's in kindergarten. He said use
Yes.
3 plus 2 is equal to 5. So that's
Awesome.
you got the
Awesome.
answer.
Thank you so
You're
much.
welcome.
Yeah, so we can think about what number plus 2 it gives us 5, and we know 3 plus 2 is 5. Great. Some other ways you might have done is just even adding on to 3, 4, 5. For many of us, it's often just automatic at the moment, right? So now's our next one. And I want you to think about how you can use this problem to help you solve the next expression. So 5 minus 2 and 1/10. How could you determine the value of this expression mentally and think about what you know about 5 minus 2, how you might use what you know about 5 minus 2 to help you solve that? If you have an answer, you can go ahead and put that in the chat. Um, or if anybody wants to come off mute and share how you are thinking about it, you can go ahead and do that too. What would 5 minus 2 and 1/10? Who's able to share how you got that? Thank you. Whitney, you want to share how you thought about 5 minus 2 and 1/10? How did you know that that is 2 and 9/10?
Use 3 minus 0.1, so got 2.9.
So let me see if so you said 3, and then you said you knew 5 minus 2 was 3, yes? And then you had 1/10 less, was that right?
Yeah,
Awesome.
so 3 minus 0.1, so
Yeah.
that's 2.9 comes from.
Awesome. Great. So 3 minus, we knew 5 minus 2 is 3. We can look at the whole numbers. And then 1/10 less than 3 is 2 and 9/10. Great. Another way we could have thought about it was maybe even using that strategy that we heard before, that adding up strategy. 2 and 1/10. How many tenths does it take to get to 3? It takes 9/10 more. And then from 3 to 5 is 2 more. All right, next. So think about what we've done in the previous two now to help us determine the value of 5 minus 2 and 17/100 mentally. How could you use what you know about 5 minus 2 or 5 minus 2 and 1/10 to help you think about that mentally? And don't be shy to put in the chat, knowing that I might call on you to share out. All right, so maybe some of us are thinking about it using that adding on strategy. That adding on strategy would sound like how many more hundredths maybe does it take for me to get to 2 and 2/10? It would be 300ths, and that would give me 2 and 2/10. And then 8/10 more gets me to that 3. So 83 hundredths would get me to 3 wholes. And I know that 5 minus, excuse me, I'm at 3. 5 minus 3 is 2. So I would have 2 and 83 hundredths. And the last one, and I'm not going to ask us to do this, but just so that you can see, here's a one that's a little bit more challenging. Just so you know, this is a 6th grade number talk, right? So you can see how the different expressions are building on each other, and the students are asked to think about how they might use the previous learning to help them figure out the expression mentally. And so a lot of times what we want our students to do is really think about, what do I already know about addition and subtraction, maybe with whole numbers, and how can I apply that now to my new learning with addition and subtraction with decimals, let's say. So here we would want students to see the connections among the different expressions would be like, they all have 5 minus 2, right? They have a 2 in the ones place, I should say. 5 wholes minus a 2 in the ones place. That's something that's similar. Something that's different is that as we went on, it became like a little bit more than 2, right? So if 5 minus 2 is 3, then I know my answer has to be a little bit less than 3 because I'm subtracting a little bit more than 3 each time. So here's one of the routines that exists within our new curriculum that's really designed to support our students in making sense of expressions and how to solve them mentally, and also making connections between what they know about the different values, the number values, and here we see decimals, how it relates to addition and subtraction, even starting off in 5 minus 2, and we had our kindergartner actually solve the first one, right? So you could see how we're bringing in kindergarten knowledge and building on that throughout the number string. Okay. So here's just all 4 of them that students would do, and we'd have a conversation around the different strategies, the different expressions, and then how place value helped affect the value of each of these. So just thinking to yourself, right? How would a routine like this is a math instructional routine, help to build curiosity, excitement, and confidence at the start of a lesson, right? So we started off with Miss Yimin Lee, who shared that her son had helped us solve 5 minus 2, right? So we could see that even built the confidence of our kindergartner students who are like, yes, I know how to ask this one. Our next one, 5 minus 2, 2 and 1/10. We heard like, oh, well, I know it was just a little bit more than 2, so I took away a little bit more, a little bit from that 3 that we had, just a little bit away from that. And that's how I got my answer, right? And then we continue to see how that builds as we get more, move more to the decimal place value. Okay, so I'm going to share a little video. It's a little long, it's about 7 minutes, which might feel long, but I think it's a fabulous video to help us understand what addition and subtraction looks like, especially in the early years, right? Because this is, as you can see, we just looked at a 6th grade task. This is really going to help set the foundation for our students as they continue through the grades. So I'll ask you as you're watching just to think about what you notice about how the math is progressing through K to through 2nd grade, and what types of things you can do at home to support this learning.
There's so much happening in the early years of school that at times it's hard to make sense of it all. So here's my attempt to make sense of the progression of addition and subtraction. So Addition and subtraction begin in kindergarten when students begin to count. They begin to count objects and sets. They do this by counting forwards, and they also do it by counting backwards. A big thing to remember is when we're counting forwards or backwards that we include the number 0. And when we're counting backwards, let's not have them include blast off, because blast off isn't necessarily a number. As students work on counting, they begin to count sets. So here a student will have 4 in one hand, 3 in another hand, and they're not able to put those two sets together. There'll always be a set of 4 and a set of 3. Then as students move from counting sets to joining sets, they're able to combine the 4 and 3. So 4 and 3 more is 7, or 4 plus 3 is 7. As students begin to work on this idea of joining sets, we introduce 5 frames. And to be honest, I don't know if they get enough play in the early grades. So we'll have 4 and 3, and students begin to build an understanding of 5 frames and filling up a 5 frame. Students can see that 4 plus 3 is the same as 5 plus 2. And this understanding will build with students when they begin to use 10 frames later on. So in terms of subtracting, students can have 4 minus 3 and use a separate model, or they can also use a compare model. The big piece here is that a context should always drive the strategy that students are using. So as students are working on addition and subtraction, they're simultaneously working on this understanding of counting and collecting and grouping things in 10. So here 13 could be seen and should be seen as 10 and 3 more, or 10 plus 3. It's here that this whole idea of unitizing is introduced. It's massive, and we need to make sure that students don't leave kindergarten and first grade without this understanding conceptually. So as students dive into first grade, they begin to explore sums greater than 10. So what might that look like? Well, here, a student can take 9 plus 7, model it with a 10 frame, and because they've worked on this idea of unitizing, or they're beginning to, they know that it's most efficient to, say, fill up a 10 frame. So they take 1 from the 7, give it to the 9 to make a 10, and they're left with 6. Here students are beginning to think flexibly about numbers, and the same understanding applies to double-digit numbers. The big piece here is that students, as long as they're using concrete models, they're also drawing representations. So what did we do? We want to make a 10. So we're going to take our 1s and bundle them up to make another 10. Decompose the 8 into a 3 and a 5, give 3 to the 37 to make 40, and have 5 more. So what does this look like with subtraction in first grade? Well, in first grade, students are only subtracting multiples of 10. And here, 37 minus 20, they can see if they remove 2 10s, they're left with 17. So what happens in second grade? How does this build on what they've learned in first grade? Well, they might use 2 two-digit numbers. And here is where we begin to introduce base 10 blocks, because of that whole idea of unitizing that students are still developing in kindergarten and first. Again, just like before, we'll draw a representation for our model. We'll create another bundle of 10. And here's how students can begin to move from the concrete to the representation to the abstract. Now, it might not be efficient, or students might see that it's not efficient to write it out on the side all the time. So, to become more efficient, they can begin to use this understanding of partial sums and find a shortcut. 8 plus 3 is 11, 40 plus 30 is 70. And this understanding of partial sums, well, it leads brilliantly into their understanding that they begin to develop with partial products in fourth grade. So that works for addition, but does it work for subtraction? Well, we want to try and use models that continue to work the same and consistently throughout math. We don't want them to expire. So here we want to have 83, and we'll go back to that separating model. We want to put 29 inside there. Well, we need 6 more. So this is a really big understanding for students, where they make that fair trade and that idea of unitizing. So now we can take the 6 from the 10, and we're left with 4. So how can we move again from the concrete to the representation to the abstract? Again, everything that we're doing here and all the work that we're doing, we're not undermining place value. And what's great is that this model, this understanding that we're building, well, it also applies to larger numbers as well. Now we can use place value mats, we can use just open sheets of paper such as this, but anyway, students are still acting out that fair trade and they're making sense, the regrouping of numbers. So what does this look like as we begin to write it as an algorithm? We'll regroup the 20 into a 10 in another group. It's all about students seeing the math conceptually, and we're not undermining place value. So as students dive into 3rd and 4th grade, they have 2 years to begin to formalize this understanding of subtraction and addition with regrouping and unitizing. But the big thing is that it's built through conceptual understanding. The standard algorithm isn't an expectation until the end of 4th grade, right before students dive into decimals with 5th grade. And you know what? In 3rd and 4th grade, if students need to use expanded form to make sense of what they're doing, let them do it. It's all about the conceptual understanding and allowing students to visualize the math. So there's lots happening. As we've said before, let's take our time. The turtle won the race.
Okay, and so hopefully, I know I had seen something in the chat around how students are learning math. As we can see here, right, the importance of our students in kindergarten to 2nd grade really having a good, strong foundation of addition and subtraction using those models, which is going to support them in being able to eventually move to more of those procedural type strategies of using standard algorithms, right? And I'll just even ask you to think yourself, how many of you were, when I showed that last expression mentally, the 5 minus 2 and 1700ths, how many of you had to think for a moment around what that how you could go about solving that equation mentally, right? And most often it's because we've been so programmed to just writing things down on paper and crossing out our zeros, carrying the ones, and all those other tricks and tips that we learned ourselves when we were in school. And we don't often think flexibly about the numbers, right? But in order for our students really to be successful in mathematics, we need to ensure that they have lots of opportunities to use models, that when we're talking about math, it's used in context, right? Not just numbers. We actually put the math numbers into context, and we're supporting our students in having good number sense. Okay, so here's just a little bit around what math looks like for addition and subtraction across the grades. So in K to 2, as we saw, they're adding and subtracting within 10. They actually don't need to add fluently within 10. They only need to add fluently within 5. So that means if I show them 2 plus 3, as we saw the young boy say earlier, or I did 5 minus 2, we heard the kindergartner say, it's 3, right? That would be that fluently within 5. In 1st grade, they start to add and subtract within 20, but they will eventually become fluent in adding and subtracting within 10, right? So thinking about all those different families that help us make 10, adding and subtracting. And then within 2nd grade, they're adding and subtracting within 100, but only need to be fluent with adding and subtracting within that 20. So you can see how that addition and subtraction understanding builds from kindergarten to 2nd grade. Again, when they're adding and subtracting just within 10, 20, or 100, they're using models fluently within 5, 10, and 20 from K to 20, K to 2. That's where they have to just see it and be able to think about what their strategy is and come up with their answer. In third grade, addition and subtraction, they start to add and subtract within 1,000. Fourth grade, they're fluently adding and subtracting multi-digit numbers using a standard algorithm. So as we saw in that video, right, it's not until fourth grade where they actually have to use the regrouping method to help them solve addition and subtraction problems, right? So up until this point, it's not something that students have to use. It's not a strategy they have to use. In fifth grade, they start to use concrete models, drawings, or strategies based on place value, properties, operations, and their relationships between adding, subtracting decimals to hundreds. So in sixth grade, their addition and subtraction moves on to decimals. So we've moved away from whole numbers now to decimals, and then eventually also, excuse me, decimals and also fractions. And then in sixth grade, they come back to adding and subtracting with evaluating and solving one variable equation. So some of the work we'll see in sixth grade might look something similar to some of the earlier grades, but now it's just replacing a question mark with a variable. And then they're also adding and subtracting integers, right? So thinking about positive and negative numbers. As we progress to seventh grade, they're thinking about, again, adding and subtracting using rational numbers. So again, positive, negative numbers, fractions, decimals, all of those go into seventh grade, and then how they also apply to solving equations with rational numbers. And then in eighth grade in algebra, they're solving linear equations and functions in one variable, right? So we'll see later on a function machine, and we'll also see how the function machine builds on learning from our elementary grades. Here are some of the things that students focus in on across the grade. So in K-2, it's a heavy on those visual representations. They're really talking about the different ways that we can make 10. They understand subtraction both as taking away and finding the difference. They can also use strategies such as adding on, as we heard I believe it was Whitney said earlier about adding on. Oh, no, sorry. It was our kindergartner who talked about adding on. And they're thinking about multiple solution strategies, right? So what are the different ways that I could solve this one problem that I have? In 3 through 5, they're thinking about understanding place value deeply. So we saw even in the video where the base 10 blocks start to come into play so that students can really understand what the ones, tens, hundreds, up to thousands, and then eventually to millions in fifth grade look like. They're thinking about multiple methods for solving other than just memorizing the algorithm. They're using things like number lines. They're decomposing numbers strategically and still moving from the concrete to the representational to the abstract. In 6th through 8th grade, we're really focusing on making sense of negative numbers. So now we're still adding and subtracting, but the types of numbers that we're using has changed now to include negative numbers. They're thinking about subtraction as adding the opposite. So if I have, let's say, 5 minus 2 before, right? That was the problem that we started off with. We're really thinking about it as 5 plus negative 2, right? So that's what starts to happen in middle school, and knowing that 5 plus negative 2 is still the same as 3. They're representing addition and subtraction in those algebraic expressions, and they're beginning to develop rules, general rules from patterns involving addition and subtraction. So I'm going to talk a little bit about the Amplified Desmos curriculum and why this curriculum really supports this type of learning across our grades. This curriculum is very heavily problem-based. Our students are learning through the tasks, not just having the teachers up there talking the whole time. They're talking with each other about how they solved the problem. They're using drawings, they're using models, number lines, and the tasks that they have are really asked them to use reasoning instead of speed. So on the right, we have an example of a kindergarten task representing addition, where it says count out 4 counters, add 6 more. Now there are blank in total, right? So they have to come together with how many counters they have. The way they come about it is up to them. They could use that 10 frame. They can just count by ones. They can count by twos, however to come to it. They could break apart the 6 into 5 and 1 and add one more to the 4 to get 5, and then know they have another 5, and that gives them 10. So lots of different ways that kids can come up with the solution, and then they talk about together how they came up with it. I did link in the slide deck also an article from Amplified Desmos Mathematics that addresses problem-based learning. So if you'd like to just read a little bit more on that, you're welcome to there. The curriculum also has embedded in it all these different warm-up routines that are designed to build fluency and reasoning. So we started with that number talk from 6th grade that you see on the right-hand side. In kindergarten, they're using all of these routines as well, but I just tried to pull a routine from each grade to kind of give you an idea as to what they are. So in kindergarten, when they're thinking about counting, it's really about the how many do you see is like we show you the image, how many dots do you see, how did you see them? They're working on that idea of subitizing and being able to see that up there's 5 dots there. When I see that grouping, I know that it's 5. In 2nd grade, we have the routine true false, where similar to the number talk, they'd get one equation at a time and have to think about, is that true or false? So for example, 10 plus 27 plus 3 equals 40, right? Kids can think about it however they want. They can add the 10 to the 27 to get 37 and add the 3 more and say that that is 40. So yes, that's true, right? But then when we come down to the last one, 3 plus 47, I could have done 47, 48, 49, 50, and then 10 more is 60. And yes, that one is true also. Sorry, I thought that one was not true when I'm looking at it. And then they're having conversations with each other, talking about why they say one is or is not true. Which one doesn't belong? They get 4 images and they have to think about how 3 are alike and then which one would not be alike according to those characteristics, right? So we see here for 4th grade, we see the place value, we see the number 245, we see it written in expanded form, we see it written in words, and they would have to think about which one doesn't belong and why. And then in Algebra 1, we see an example of a function machine that asks them to notice and wonder, right? So as the function machine drops out new numbers, kids are asked to think about what are some things that you're noticing and some questions that you have. The curriculum also has digital tools. It is more heavily, or has the ability to be more heavily digital, I should say, in middle school. In elementary school, there's only a few different, a couple of lessons within each unit that are designed to for students to engage with digitally. Here's a sample of a digital, a slide from a digital lesson for, I believe, 1st grade, right? So we could see here, it said, how many more carrots did Danny pick than Lola? You can see what it's highlighted there. And then, so we had kids would count how many carrots Danny had. There was the 5, 6, 7, 8, 9, right? And then Lola had 4, so they'd have to think about how many more. And kids can annotate their thinking up here and they get automatic feedback. So I put in an wrong answer on purpose just so you can see what happens when they put in the wrong answer. They could see that 6 is 1 too many, so I need to readjust my answer to be 5. The curriculum also does a great job of building coherence across the grades. So we can see in 1st grade that idea of the tens frame being on the kitty roller coaster, right? So the cats actually, we had 6 cats, 6 gray cats in the roller coaster. Then there were 7 tan cats outside the roller coaster. How many cats do we have? So you have to fill the cart to see how many you have, and you can see that 6 plus 7, when I add those 4 back into the 10 frame here in that roller coaster to fill it up, that makes that 10, and then 3 are left over to give me that 13. So I could see that 6 plus 7 is 13. In 2nd grade, we're continuing on with that idea of 10, but now building more towards thinking about that base 10 model, right? So a group of 10, we can see the 10 frame that they have on the right. But then also that idea of like needing to regroup. If you have 34 minus 7, you'd have to take from that group of 10. You can only cross out the 4, and then you'd have to take 3 more from the group of 10 to get your 27. And then in third grade, we see the base 10 models, how they connect to that idea of um, expanded form, right? And then also using place value to add and subtract. Oops, sorry. So I'm going to ask us now to actually do some math with me. We're going to experience some kindergarten, some math tasks from kindergarten all the way through Algebra 1. If you would like, you're welcome to join the digital classroom that I have here. If you want to experience what it's like to do some of the math as a student in our classroom, you can click that link. Louis, are you able to put that in the chat for everybody too? So you can click the link, you'll join my activity. You'll just click start activity. And then when you come to it, you'll see that it's paused. So I paused it for us just to see, let everybody join that wants to join. So I see a couple of us. I think that's just me that's actually in. I can actually see as a teacher how many students have joined my classroom, or when students are working, what slides they're on, what their thinking is. So it gives me, the teacher, also lots of great feedback on the students. Again, in elementary school, pretty much only 2 to 3 lessons per unit are digital. In middle school, they have the opportunity to do about 75% digitally, although teachers are making really thoughtful decisions around when to use the digital with our students and when to also use the workbook, the traditional pencil and paper. And I see across classrooms that students enjoy both opportunities.
So the link is in the chat. I do encourage everyone to click the link in the chat and join in on this activity. What's interesting is you'll be able to see the student perspective, which is going to be on your screen, and the teacher perspective, which is going to be on Zoom on Beth's screen.
Mhm.
Okay.
So your screen looks like this. I'm going to just kind of man it a little bit in the background. And we're going to start with kindergarten. So I'm going to ask once I unpause you, what you're going to do is, actually, let me come back to here. You're going to look at slide 2. This is a notice and wonder. So actually, maybe I'll play this one aloud for us. And then just think about what are some things you notice and wonder. And then you'll go into slide 3, where you're going to do as many problems as you can. So we'll see how we can use the notice wonder to help us do as many problems as we can to think about how many buses there are, right? So let me unpause us. And I'll play I'll play our video here. And just think about what are some things you notice and some things you wonder. Hmm. And so in our classroom, we'd have a conversation. Kids would have a chance to talk to each other about what are some things they're noticing, some things they're wondering. They might have noticed that the bus was on its way to school, that there were 4 buses already in the parking lot. Then that bus took a spot next to those 4 orange buses, and now there's 5 buses, right? They might also notice that there's 10 spots available for them, that there's 5 more buses that could potentially park there. Some kids might wonder how many buses are there if that's where they're at, right? So what you're going to do is you're going to go on to slide 3, and there's a few problems there. You're going to do as many problems as you can. So notice there's 1 bus already parked, and then there's 3 green buses that need to park. So you'd think, how many buses are there? You can choose the number here. I'll just model it for you, and then check it, and then try another one, right? So you I'll also challenge you to just try putting in a wrong answer and see what happens if you put in a wrong answer. I'll give you just a minute to check to play around with that one. Think about though, as you're playing, what's the learning and what models do you see? All right, and I see a few of us playing around with it. If you are just following along with the screen, I'll come back here and we can try another one. We'll see what happens when we get a wrong answer, just so you can see what happens. And so for students in kindergarten, it's actually doing the counting for them. They could see that the answer would be 6, right? That there was 4 here, and then the 2 more gives us 6. So we try another one, hoping that they know, oh, look, it's the same 4, and then I add 1 more to get 5, right? Okay, great. So now what I'm going to ask you to do is just think about what are some of the models that you saw being used there, or what's the learning? If you want to put in the chat or come off mute.
How many are there?
How many are there, right? That's the learning. How many buses do we see in all? Awesome. Thank you.
Count.
Any other models that we saw?
I am learning adding and counting.
Adding and counting, right? So we're learning to count by ones up to within the number 10. So remember, I was saying that for kindergarten, they're thinking about adding within 10. They have to be fluent within the number 5, right? By the end of kindergarten. We also see that it looks like that 10 frame, right? They've taken the buses to fill that 10 frame. So we could see that students might automatically see that when the whole top row is filled, that is 5, right? Or if I have one more bus and there's 4 there already and I add one more, that would just be 5 without even having to count. Awesome. So now we're going to move on to second grade. My kindergartners have passed the test. They're moving on to second grade. I'm going to stop pacing us here. I'm going to pull you guys to me, and I'm going to pace you now from 5 to 8. And so in second grade, as we move on, what you're going to do is see some tape diagrams. I'm going to give you a moment to just explore the tape diagram. Again, we see that. What do you notice? What do you wonder? See what happens when you drag it. Also pay attention to the language of the problem. And then you're going to spend some time looking at a tape diagram here, right? It's the original, the first story is the original way we saw it. And I'll ask you to think about the tape diagram, the story, and then the second story tape diagram and the third one, and think about how are they the same? How are they different? What's different about the tape diagrams? What's different about the stories? What's the same about each of them? And then again, just think about what is the different models that we see here? And also, how does this connect to what we just did in kindergarten? Can you see any of those connections between the two of them? So I'll give you a moment just to explore those. You're not you're not paused, so you can actually go through 6, 7, and 8 at your own pace. For anybody who's just following along on the screen, I'll just kind of share some of the things that families at home might be doing, thinking about what are some things you notice, what are some things that you're wondering. Okay. And hopefully we saw that in the tape diagram, we were always working with that number 40, right? First, we started off with 18 Flowers, 22 fish beads. The 18 in purple represented the flowers. The 22 fish were represented by the blue. And then we were asked to find the total. In story 2, we actually know the total, and we still had those same flower beads. We wanted to know how many are fish beads. So it's beginning to think about the connection between addition and subtraction and how we can use what we even know about addition to help us figure out subtraction. And then story 3 is now the opposite, right? So we know the whole still is 40, and then we know the part is 22. What's the first part that we were talking about? And so we can see here, right, how the idea of that part to whole, even in the kindergarten, we had the part of the buses that were parked, and then we have the other buses that are going to park. That's the other part to figure out the total. I'm going to move us a little bit faster because I'm looking at the time. My timekeeper just gave me a message. Thank you. Get carried away when we're talking about math. And so for fourth grade, we can see here that we're adding tokens to the place value mat. Again, what do you notice? What do you wonder? So they're looking at the place value mat. They can add as many tokens as they want, looking to see what happens when I add more thousands, what happens to my numbers, what happens maybe if I add more ones. Can I go past 10 ones? What happens? What happened to my number when I actually went past 10 ones? Here in my ones column, it's 0, but when I had 11 ones, actually, I only have a 1 in my ones column when I look down below, right? And they're thinking about adding all the different values of each place value together to get this total number. It moves on then to think about how you can represent a number using fewer tokens. So again, that idea of like regrouping still even looks like that 10 frame. When I look at the tens column, I see like that 2 groups of 5 as my 10, and I should know that that is a group of 10, and 10 tens can be moved to the hundreds. So that would be fourth grade. And then in sixth grade, come back to something that might look more like what we saw in the lower grades, where it's we have to figure out, what plus 3 equals 7? Again, a notice wonder, they're moving the balance scale to see what happens. They could see that at 4, when they have 4 pounds here, it's balanced. But if they add too much, it's not balanced anymore. They continue on for the lesson in sixth grade, thinking about how much the dog has to weigh. Sorry, I was playing around with the wrong answer to see what happened before. But so I can see what happens when I put in the answer, right? How much does the dog weigh? If he weighs 17 pounds is on one side, what number plus 5 gives me 17? If we put in the wrong answer, you can see what happens. Kids can see, if I thought it was 10, I'm close, but I still need a little bit more, right? And so they can go back and change their answer based upon what they just saw happen. We notice what's happening here in sixth grade is now we're moving on to variables, right? So we place that, what number plus 5 is 17 with the letter D. They're introduced to the variable in sixth grade. And then as we move on to algebra, right? Thinking about addition and subtraction, where we see it, that idea of subitizing and the importance of it in the earlier grades is helpful here when they're thinking about how many tiles are in this figure without counting. So how are we grouping? Maybe you're seeing 4 groups of 3, right? To be 12 and 1 more. And then how can you use that also, those groups, to help us think about how many might be in the next figure. So we see here how the figure is growing. They have to think about how the figure is growing. They have the table here, thinking about how they can find out how many are in figure 4. So they look for the relationship between the figure, the number of tiles. They might see that it's adding 4 each time and continue that to get to figure 10, eventually to find a rule for how many tiles you would be able to find in like the thousands without adding 4 1,000 times, right? So there we can see I'm sorry, I just have a lot on my screen. How the math looks in our curriculum for addition and subtraction across the grades, a brief view, sorry, of the mathematics. Here are just some models that we saw a few of them as we were looking, some models that you might want to use with your children if they're in K to 2. Thinking about fingers as a kids start off with counting on fingers. They have the abacus, they can use the counter dots, the 10 frames, even just number values. Starting in second grade, they're bringing in the number line. In first grade, they're thinking about also um, the bar model, excuse me. And then in 3 through 5, continuing with the bar model, right? Our place value, excuse me, our counters have kind of been replaced with the base 10 blocks as we see here, thinking about adding by place value and continuing the work of the number line. 6 through 8, they're still using that bar model. Now they're using it though for algebraic purposes. So their unknown has been replaced with a variable. The balance scale is another model when they're thinking about adding integers, bringing back those red and yellow counters, right? Our yellows would represent the whole number, the positive integers. Our red would represent the negative integers, and so they can see how they cancel out. So if you have 4 plus -2, that why it's just 2. And then even in algebra, as they move on towards the function machines, right? So like, what number would I have to put in for x that when I do x plus 1 will give me 4? All right, so just as we're coming towards the end, ask you to think about how the math changes across the grades. Was there anything that surprised you? Anything that surprised you, you can go ahead and come off mute or just share in the chat. I'll give you a moment to think about it. For those of us with kindergartners at home, maybe you can see how our math is building to get towards 8th grade. I see someone said the visuals are confusing. I'm doing a super quick overview of them. And so if they are confusing, I'd suggest maybe just even I have some resources that you might want to look into a little bit deeper around how to use some of them. I think they're not as comfortable maybe for us because either one, we use them quite a long time ago, or maybe we never use them in math class, right? But for students to be able, we started off in the video talking about kids playing, right? So seeing that math can be learned through play. How many in all, how many parks? So the questions are not perfectly clear. And I think they're perfectly not clear because for this purpose, it was around the discussion, right? The fact that there was how many buses are there? The way I set us up was that we had the number that were parked and then one more. And I said, how many buses? Maybe I should have said how many buses were parked. Sorry about that. All right. So moving on, I'll just share a few resources with us that can support our learning at home or provide helping our students learn at home. There is a link in this slide deck for a tip sheet that the Central Math team has put. You can click on the image and it will take you to it. And you can access it that way. But I'll just highlight a couple of things that were in here. So for parents and guardians, ask you to think about doing more of letting your kids know that you believe in them, even when math can be hard sometimes, right? Reminding them that everyone struggles sometimes, and that struggle is the way that we learn. Even for us to say, I appreciate you saying, like, I don't really understand the visuals, right? If we had more time, I'd sit down with you and explain them a little bit more to you, but maybe even asking our students to explain them to us to help us understand them a little bit better. Instead of saying to our kids, you know what, I just wasn't a math student either. It's okay, honey, if you don't understand math, right? So while this might seem comforting, it actually is doing a lot of damage for our students, helping them think that it's okay if they don't do well in mathematics, right? Another thing we want to do more of is really just talk with our kids about math that they're working on, asking questions like, how did you figure that out? How do you know if your answer makes sense? Instead of just giving them the answer or going through, here's how you do it. First, you have to do this, then you have to do this, right? Because then that becomes more about memorizing procedures. And while it might do well for that given moment, you can see as the math progresses through the grades, how if a student only knows the steps to that one problem, they often can apply it to the math further on down as they progress through the years. Just thinking, I know we're a little bit late on time. What are some things that's worked for you when you've supported your children's math learning? If you want to go ahead and place that in the chat, or any advice you have for other families, you can go ahead and jot that in the chat as I just share a couple of last resources and some next steps. In the slide deck, there's also some questions that you can use to ask your child as you're doing math. More things like around, what do you need to figure out? What have you tried so far? Can you describe where you're stuck? Does your answer make sense? Or even, is there more than one answer, right? So where somebody asked around, is it the parked cars? Is it the cars altogether? Is it the cars that are going to park? My question would be like, what problem are you answering, right? And then what if my question was this? What would your answer be? I did summarize tonight's learning in a document, so if you would like to access some of the things just in a printable document, you can go ahead and print this here. I translated it through, I don't know what we use, Adobe Express, so if it's not translated well, my apologies. But you can go ahead and click here. That's in Spanish, and then there's also an English and a Chinese version from tonight's learning. And just even for yourself, you don't have to share it with us, but just think about what's one thing you commit to doing at home to support math learning with your families. If the visuals are a bit of a challenge for you, maybe what you might want to do is commit to learning one of them, understanding how the 10 frames works, right? Or understanding how those place value works if your students in 3rd through 5th grade, or even understanding how the balance scale can be used to understand solving equations with variables. Additional resources, I've shared these in the past, but I still come back to them. I think they're great. Bedtime math, if you're thinking about ways you can talk about math with your students, bedtime math really connects literacy and mathematics together. There's a link here for some different games you can play and some different challenges. And then if you'd like to watch the video we watched today, there's the progression videos are here. He does also have them in Spanish. So if you'd like to watch it in Spanish, you can click the link and download it in Spanish. Amplify Desmo's Caregiver Hub is here. If your child is using Amplify, you can go ahead and check out some of the resources there, or just even if you want to get a heads up around what the curriculum offers for families, you can click that. There's some virtual manipulatives and an article around addition and subtraction models and strategies. So we'll talk a little bit more about some of those different models. Almost lastly, we have our Math Madness nights coming up. They will be posted on the website soon. Our first one is January 22nd at PS 129. All from the district are welcome. It's a great time to just come and do some math with your kids, play games, talk about math, have lots of fun. I promise you, many of you probably won't even realize that you're doing mathematics as you're playing a game. They've been a huge success in the past. Hopefully you can come and join, and we can even talk about some of the things we talked about today a little bit more in depth. Our next session is on Wednesday, January 28th. It will be on multiplication and division across the grades, similar to tonight's structure, but now we'll be thinking about multiplication and division and how it lives across the grades. Any questions, you can go ahead and put them in the chat or come off mute. And then my email is also linked in the slide deck if you'd like to share some feedback or have a question, need some support with something, a math problem, feel free to go ahead and email me. But questions, I'll go ahead and give everybody a moment to share a question if you had it.
So I just want to remind everyone that the slides for that were shared today are already available on the website, and I put the links in the chat. But I will also email them out to everyone who RSVP'd for this session tomorrow, along with the recording of the session. So you'll have all that in one place. And I'm also going to encourage you all to subscribe to our YouTube channel. We upload all of our public facing meetings recordings there, whether it be CEC meetings, DLT meetings, and all the workshops we do for families. So if you subscribe to us, you'll get notifications when we upload new videos. So please do that. And I don't know if Dr. Mike, I see Dr. Mike is on. If you want to say anything, Dr. Mike, while we get questions ready. I don't see anything right now.
I see
Yeah, no,
one question.
Beth, thank you so much for presenting. Sorry, it took me a little bit longer than I was hoping to make it on the virtual space. I was listening the whole time to you guys, and I know sometimes when we think about math, we do go right to standard algorithm and the way that we may have learned when we were younger. But I do know that the importance of making sure that our kids can think flexibly in math. And I think mostly about that. I have a 14-year-old, I have a 16-year-old. Sometimes when problems are not as neat, they have a difficult time identifying how to go ahead and solve because they haven't become necessarily problem solvers, mostly because the conceptual space has become a little bit more difficult. So when we encourage our kids to think about math flexibly, we're promoting the space of becoming a problem solver. And that's ultimately what we want our kids to become, that they can see a problem, think through it flexibly, and establish some kind of solution set that makes sense. And that's the direction we really want to push for our kids. It doesn't mean that there won't be a place for standard algorithm. It doesn't mean that disappears or it's not appropriate any longer. It just means that we're creating opportunities for our kids to think more flexibly in mathematics. So I thank you for your time. I thank you for being a part of the session. And just to notice that the progression for this is then into multiplication, division, and then certainly into one of the more troubling components for our kids, and that's in fractions. As things become more abstract, they become a little bit more difficult for some of our learners to hold on to. So I do encourage you to continue to stay tuned as the year goes on, and then certainly ask those questions. We get better and smarter when we hear from you and can make adjustments over time. So thank you so much for being here. I know Tuesday before we're getting into Thanksgiving time is not always easy, so I appreciate your willingness to hop on board with us tonight. Everyone enjoy your Thanksgiving, and if you have questions, certainly we're here for you.
I have a shout out from Chantel. Thank you. That math event is fun. Highly recommend. So thank you for that.
And we're gonna message out to everyone with those dates as we get closer. So this was just you guys are gonna get the first tip on when the dates are gonna be, but we're gonna message those out to everyone. Was the question you saw?
And then Tasha
yes.
asked, how would you suggest catching up in math, catching a student up in math if they feel behind or if they're falling behind? I think if take a look at even some of the learning that we did today, I'm not sure what grade that your child is in, but or a child that you're referencing is in, but if they're in the earlier grades, you can go back to the video just to even see where some of that learning might have been missed. Going back to even just that idea of using the 10 frame, students often that are struggling with addition and subtraction even have a hard time with supertizing. So knowing that like what 5 looks like, they often have to go back and count everything, or even when there is 5 and then they've counted 5 and then add 2 more, they go back and count 1, 2, 3, 4, 5, that way, not even knowing that I already counted that 5 doesn't change. And then what's the 2 more? Or taking a look at how the math progressed through the grades, trying to pinpoint maybe some of the places that they're struggling, and think about some of the different models that I've shared with you in the slides, and then also in the resources that are linked in the slides for you. The other thing I would just say is do math as much as you can. Talk about all the different ways that math lives in the real world, right? cook together, go shopping together, talk about all the math that's involved. The more you are having those conversations, making math into, like, let's say, a game with your child, they're more likely to catch up than if it's just looked at as it's time to do your homework. Let's go sit down. Why are you not getting this? Right? That could be very stressful for the student, also for you, and cause a lot of arguments at home, and then cause the child to just kind of feel frustrated and not want to continue on. So making math fun, there's a list of math games there. Try those math games just to help build that numeracy, that number sense and fluency, are great ways to support.
There's another question in the chat at the bottom, similar to the one we just did around
Yeah. I would say fourth grade struggles in basic calculations, um, although flies through advanced math concepts. Again, just like the idea of seeing those number talks. You know what? I'll have to find. If you email me, I'll send a link to some to a site that has some of those different number talks that we started off with to help build those basic calculations, how they can see how they use their understanding of a previous problem to help them solve the next one and think about all those different connections. That would be helpful. Thanks. Yeah. Is there a focus on math word problems? So I did not focus so much on that, but maybe actually that's helpful feedback for the next one in multiplication and division. I'll build in a few more word problems also and think about some of the strategies that we can use to help also uncover the math word problem. So thank you for that feedback.
All right, guys. Any other questions or comments you want to bring up before we end it for today? Like I said, I'll email everyone tomorrow. We have a busy day tomorrow, but I'll find time. I'll put the YouTube video up and I'll send an email out with all the links to everything, including that great video that Beth played. I thought that was a really great video that shows at a very high level how all the different grade levels, each grade level, how it builds upon each other. All the learning builds upon each other. Okay.
All right, well, thank you, everybody. If there's no more questions, I appreciate all of you coming to join tonight. I know it's a busy week with Thanksgiving. Wishing you all a happy Thanksgiving. Hope you do something, spend some quality time with your family, and enjoy. Think about all the math that's involved in Thanksgiving, whether it's paying for your groceries or the amount of time it takes to cook things or making all your recipes. Lots of math that's going to go into your weekend.
For sure. All right, everyone, have a great night, and
Have a great night, everyone.
next
Happy
time.
Thanksgiving to you.
Thanks, guys.
Thanks.